Okay, so today we're going to talk about two very specific types of indices, two very specific types of exponents. We're going to look at what do you do when the exponent is 0 and what do you do when the exponent is negative. So we're going to start by looking at a bit of a pattern. So if we think 2 to the power of 3, what does that give us? Well, 2 times 2 times 2 gives us 8. If we think of 2 squared, that's 2 times 2, so that gives us 4. And 2 to the power of 1 just means 2. So what is the pattern here that exists between these? Well, 4 is half of 8. So if we took 8 and divided by 2, that would give us 4. If we took 4 and divided by 2, that would give us 2. So can we use that pattern to keep going? So if we sort of follow that same line of thinking, 2 divided by 2 again should give us that next exponent. So 2 divided by 2 gives us 1. So that means 2 to the power of 0 is 1. Okay? So if we take 1 and divide by 2 again, we will get 1/2. Okay? So if we take 1/2 and we divide by 2 again, that gives us 1/4. So keep this pattern in mind as we start working through these negative and 0 indices. So 2 to the power of 0, we got 1. 2 to the power of negative 1, we got 1/2. And 2 to the power of negative 2, we got 1/4. So just tuck that away, and we're going to look at 0 indices first, because they're by far the easiest. Zero index law. For any number raised to the power of 0, the answer is always 1. Always. The only exception to that is when the number is 0. So 0 raised to the power of 0 doesn't give you 1. 0 raised to the power of 0 actually gives you 0. But everything else, negative, positive, doesn't matter. Anything to the power of 0 gives you 1. So let's look at some examples. These are going to be pretty easy. 7 to the power of 0. Well, 7's not 0, so that means that equals 1. X to the power of 0. Well, that equals 1, but we're going to write this little condition. As long as x does not equal 0. Since we don't really know what x is, the answer to that is going to be 1, so long as x is not 0. 2 plus 5 to the power of 0. So that's going to give us 2 plus 5 to the power of 0, 1. So that equals 3. Order of operations says we handle that exponent before we do that addition. Y to the power of 4 divided by y to the power of 4. Remember back to our exponent rules. When we're dividing powers that have the same base, we subtract the exponents. So that becomes y to the power of 0. And that we know equals 1. As long as y does not equal 0. And you can think, that kind of makes sense, because anything divided by itself gives you 1. So y to the power of 4 divided by y to the power of 4, we would expect that to give us 1. Even if we follow out the exponent rules, we get y to the power of 0. Now we know 0 exponent, it equals 1. As long as x does not equal 0, or y in this case. So the negative index law is a bit more complicated, but you don't need to be afraid of it. It's going to be fine. We'll just take this one little tiny step at a time. So here's what it looks like. We have a number, or in this case, a is representing a number, and it's raised to a negative exponent. So that n is just in place of another number. So it would be a to the power of negative n. That equals 1 over a to the power of positive n. So what I need you to train yourselves to do is every time you see a negative exponent, think 1 over. 1 over, 1 over, 1 over, 1 over. And what you're going to put the 1 over is the exact same exponent with a positive this time instead of a negative. So this means that a to the power of n and a to the power of negative n are actually reciprocals of each other. So if we work that out as an example, and we start with something easy like 3 squared. Okay, well we know that that's 3 times 3, so that gives us 9. but 3 to the power of negative 2. Remember, we've trained ourselves to think, okay, that's 1 over, and that exact same exponent, that exact same power, except our exponent is negative. So that equals 1 over 3 squared gives us 9. So 9 and 1 over 9 are reciprocals of each other. Because if we think 9 written as a fraction, that's 9 over 1. So the reciprocal of that, the flip of that, is 1 over 9. So notice that when you have a to the power of negative 1, that equals 1 over a to the power of 1. And that's what we've been sort of stating all along here. When you see that power of negative, any negative exponent, think 1 over that exact same power with a positive exponent. Let's go through some examples. So 3 to the power of negative 1. We've trained ourselves to remember that 3 to the power of negative 1, every time we see negative, we write 1 over. And then we write that exact same power with a positive exponent. And then we look to simplify as much as we can. We can do 3 to the power of 1 very easily. That's just 1 over 3. So our final answer is 1 over 3. 5 to the power of negative 2. We have a negative exponent, so we're writing 1 over. And we're going to write that exact same power with a positive exponent. So that's 1 over 25. Okay, that's 5 squared. Last one, 10 to the power of negative 4, getting a bit ahead of myself. That's 1 over that exact same power with a positive exponent. Then you look to simplify. So that becomes 1 over 10 to the power of 4 gives us, let's try that again, 1 over 10,000. So let's put everything all together. Now this first one is going to be a bit troublesome maybe, but I want to take you through what the whole proof of it is, and then we'll go to the shortcut. So we've got 2/3. This time we've got a fraction that's being raised to a negative power. So the proof, this is not the way you would normally do it, this is the proof. You would have 1 over 2/3, and that will be to a positive exponent now of 1. So anything to the power of 1 is just itself, so that's 1 over 2/3. So that's the same as saying, well, that's 1 divided by 2 over 3. Okay, how do you divide fractions? You flip, and you end up multiplying by the reciprocal. So 1 times 3 over 2, well, that just equals 3 over 2. Okay, so that's our final answer, 3 over 2. Now, how can we shortcut it? Remember we said that anytime you're raising to a negative power, you end up taking the reciprocal. So when you're dealing with a fraction raised to a negative power, we're going to flip it right away. So 2/3 no longer is going to be 3 over 2, and then we change that exponent to positive. So then you end up getting 3 over 2, just the same way we did there, the long proven out method. So when you're dealing with a fraction that's raised to a negative power, flip it and change the power to positive. So this one's a little bit different. We're subtracting, so there's no exponent rule that's going to sort of speed this up for us. So 8 to the power of 0 gives us 1 minus 8 to the power of negative 1. Remember, that's 1 over, and then the power written out positive, so that's 1 over 8 to the power of 1. So that becomes 1 minus 1 over 8. How do we subtract fractions? We need a common denominator, so we're going to rewrite 1 with a denominator of 8. 1 whole written with a denominator of 8 means 8 over 8 minus 1 over 8. So that gives us 7 over 8. Okay, so 7 over 8 is our final answer. Let's look at a couple more. Things can get a little tricky depending on exactly what the negative exponent is on. So we're going to look at 2 examples that at first seem like they're pretty similar, but just because of where the negative exponent is, it's going to be a little different. So this is 8ab to the power of 1. So it is only the b that is to the power of negative 1. The 8 times the a, nothing happens with that. But then we have to multiply that then by 1 over b to the power of 1, which is just 1 over b. Think about multiplying together fractions. You could, if you wanted to, say, well, that's 8 over 1. And that's a over 1. So we multiply straight across the top, although it looks a bit messy, is 8 times a times 1. So that gives us 8a. And then on the bottom, we have 1 times b, so that's just b. So a disjointed 8a over b. Okay, let's look at the next one. We've kind of worked right up close to it here. But this -1 applies to the a and the b only, not to the 8. So this one you're going to have 8 times, and then that negative exponent means 1 over ab, and all of that's to the power of 1, so it's just going to be ab. So then you think, okay, well that 8, you imagine that over 1, so multiplying fractions, we go straight across the top, and we go straight across the bottom. So this one is 8 over ab, whereas the first one was 8a over b. So very similar, but you really got to watch what exactly is that negative exponent applying to. And that's all there is for this video. Thanks for watching.